TeachMePCB. I'm Mark, one of your co-facilitators, and I'm here with the Week 4 announcement and a little Sunday afternoon chat. So let's get going with the announcement. This week, we've got something very exciting for you. You're going to start doing your first board design. And to that end, you're going to create all of the patterns that create a land pad. This is what allows your parts to stick to it with solder. So that's really the goal this week. Now, creating custom land pads for every part on your PCB might be a little overwhelming. So we're going to set up a way for you to not only learn how to create at least one pad on your own, one part, but also to share those amongst your EDA groups so that nobody is overwhelmed. And then at the end of the week, we'll collate all of those and give them to you so that if you do struggle, you'll be able to jump back into the course without really missing anything. So that's pretty much the overview, except I've got a secret announcement. You want to see what your source code for your board's going to look like? Want to see it coded live? Yeah? Well, then join us this Wednesday at 11 Pacific. Friend of the course and sponsor Yuri Shaked, who created the website Walkwe, is going to show us his Arduino and Raspberry Pi Pico emulator that he coded from scratch because he's amazing. And he's going to show us how to get most of the parts on our board coded. I was working with him this afternoon. He's got the switches and the LEDs all good to go. Rotary encoders look like they're there. He even imported my board file. Dude's crazy. I love him. He's also the nicest man that you will ever hope to meet. So I've got that for you. But wait, there's more. Let me figure out how to share it with you here. Do I need to share screen 7 or this? And then as soon as I'm done with this, we will open it up for all comers. Yeah, I kind of want that to be bigger. Give me just a second. Let's pick a different view. There we go. All right. Something else that I've done for you is I'm going to release version B of the schematic. So version A, I tried to keep the signal to noise ratio, relatively high. I hit all the net names. I didn't put down too much information in the part sheets. That isn't necessarily good design, but I think it's good for first-time viewers to see that. Now, when you go to the schematic, which screen do I want? Sorry. I've got like 5 monitors here. I have no idea where my mouse went. Or now that I found it, I don't know where it needs to go. Ah! Let's try that again. Can I scroll maybe, please? There we go. Now let's zoom maybe, please. So now that you see all of these things, they're going to have some more information. For example, you're going to see the net labels all in red. You're going to see the parts along with the part number or description of minimum requirements in the thing. So look for revision B. That'll be out to you tomorrow. It's kind of hiding. I've released it quietly in a few different spots in some forum posts, but it's not official yet. But it'll get dropped with the all of the work tomorrow evening. With that, I've got some people waiting for me, and I'm grateful to have you. Let me welcome in Brian. And I thought I saw Emil there for a minute. And then we've also got Elliot.
Hey, guys.
Hey, how are you?
Good.
Good. Looks like Brian's hard at work doing some soldering. So hard at work, he doesn't even realize we're here or that he's on screen.
I hear you.
How you doing, buddy?
Doing okay.
Good.
This soldering project may be the end of me, but we'll see.
Do you have a Halloween costume?
I'm wearing it. Can't you tell?
Wait a second. Is that handsome Brian? I am French Mark. Whoa, stupid American. Regular Mark. You didn't even know, did you? Right? The transformation is that complete. How about you, Elliot? Anything fun?
This is evil, Mark. We won't go there.
Yep, I'm just dressed up as a 1 year older than last time version of myself.
You know what Evil Mark could do here? I think I know what Evil Mark looks like. Give me a second. What sane person would have eyebrows like this? That, and maybe I need to pet a bald cat. I don't know. Well, welcome, guys. How you doing today?
Doing okay.
Doing good. It's the weekend. Best part of the week.
Yeah, it really is. Well, thanks for joining me, and thanks for the conversations that we've been having on, let me pause notifications there. For some of the conversations we've had about the goals of the course and some of the ideas that you've had. Is that anything you feel like sharing? Or do you want to wait until we develop a little more?
I say let's wait.
I am all about that. Let's do that then. So what can we do? What would you like to talk about today or do today?
Well, since we're getting into footprints this week, right?
Mhm.
I've given this a whirl on the that contextual electronics tutorial, and then tried the other day. I made a footprint for the 5050 LED,
Okay.
and I actually found it really frustrating.
Oh,
not frustrating in the way that makes you give up, but so much trial and error. A lot of non-obvious things, like just trying to put a pad where it belongs. Felt really limiting. Like I have to use the grid and pretty much nothing else, doing a lot of math to find the centers of things in relation to other things. And it feels pretty foreign compared to a lot of the other like CAD CAM things out there where you can slap down a shape, modify it with some dimensions, move it around real slick. So yeah, I don't know if that was something we could
of
have a
course.
look at or give a try and see if there's
First
something
of
I'm
all,
missing.
yes, it is incredibly frustrating. And not without error. If we did a project like this, and I've actually got some pictures here that I'll share in just a second. But if we did a project like this where we've got, I don't even know what it is. Is it like 13 line items?
Something like
At
that.
least.
It's how many?
18?
18. So just spitballing there. If I went out and started generating the complete library for my design, I would probably find functional parts somewhere for maybe 11 or 12 of them. I wouldn't be able to find 3 or 4, and the rest I would find and they would be wrong. Now, if something's there or it isn't, that's great, right? I mean, that's binary. Either it exists or it doesn't. But if something's there and it's wrong, you still have to do a ton of work to go figure out, to verify it. And then if it is wrong, figure out why it's wrong and how to fix it. And we're just talking about the land patterns here, right? We're not talking about the 3D models or the schematic symbol, just the land pattern. Now, to that end, I've got several comments on that, and then I would be happy to go through and make one with you. So the first thing that I've got for you, I need an overhead cam. That is not an overhead cam. Is that an overhead cam? That is the wrong overhead cam. Got to rebuild my 3D printer front end. This is the Raspberry Pi Pico module, the page that's in the data sheet. Let me see if I can get a little more light on that for you. That kind of makes it worse, doesn't it? Yeah, we'll just stick with this one. And everything is given in terms of just weird dimensions that don't really lead themselves to anything useful. For example, the distance between the lower part of the pad number 20 and the upper part of pad number 1 is 49.86 millimeters. The distance between the the lower part of pad number 1 and the upper part of pad number 20 is 46.66 millimeters. What do you do with that? Well, if you subtract them, it gives you something useful. It gives you the width of 2 pads. And you're like, what's going on, guys? I mean, you're just absolutely killing me there. So one of the first things that I did when I got a hold of the Pico was sit there and do the math. Everything is translated over into absolute coordinates, right?
I considered doing this. And I was thinking, is a good workflow to actually jump into a real CAD program, draw this, make yourself a reference center point for every object, import that as a DXF, and then just make a pad, snap it to those points in KiCad, or type them in like you've got there.
It is so frustrating if you don't. But look at how much work that is. That's easily an hour's worth of work, right? By the time you're done and verified everything. So this is a part where people could potentially just throw up their hands and say, screw it, I'm out. I don't want that to happen. We will undoubtedly have at least one person who has the wherewithal to get it done start to finish, especially since I've already done most of the hard math for you. So then if we get that, we just need 3 or 4 people to verify it. And once we're pretty sure that it's right, then we can share it with everybody. So come into the week, anybody who doesn't want to punish themselves in that manner can do that. Does that kind of make sense?
Yep.
So people who are a little bit newer to things, maybe they want to focus instead of the Pico, which is the hardest problem, maybe they want to focus on the maybe one of the rotary encoders, or they want to focus on the switches, which are much simpler to do. Kind of cool or not kind of cool?
Yeah, I was just wondering, like, is there a better way other than finding one that's already existing? Because someone has to struggle through it at the beginning anyways, right?
Fortunately,
Yeah.
someone did an Eagle layout for the Pico, so I got lucky on that one. But
yeah, that's good, but you still have to verify it.
I did.
Michael says, wasn't there a diagram a couple of pages earlier in the doc that had the same dimensions? Michael, that is the... I thought I had a Pico right here. I do have a Pico right here. Where was it? Here it is. So a couple pages earlier in the Pico doc, you're going to see the spacing on these things, the 2.54 millimeter spacing and all that other good stuff. Where is the camera? Here we go. You're going to see the Pico doc describe this part. Unfortunately, you need a ever so slightly different pad size and whatnot. I don't know if we're going to be able to see it here, but these pads are, I mean, if I do them side by side, you can certainly tell. The land pads are a different size than the others. So it's not sufficient to look at that other one and put them down. Land pads are almost universally larger than the part pads. It's rarely the case that they're not. There are cases when they're not, but that's when you're getting down to really, really small stuff and other things. Fergbrain shared, but he shared it in private chat. I'm going to bring this into our comments and then share it. So this is from Fergbrain, not me. But he found a GitHub where all of that information is available to you. And again, that's a great way to go, but it needs to be verified. It's not sufficient to say, hey, I found this thing on GitHub and use it. It will bite you in the butt. Every board I have ever made has, where I've used somebody else's design files, and I use them, I import them when I can. Every single one of them, there's been a problem. Every single one. So it is never sufficient to just use something you find online, because, for our 18 line items, if one of them's wrong, you got to respin your board, right? If you want everything to work. So, yeah. Anyhow, trust but verify. Yep, absolutely. How come I can't see you guys? Oh, there's Fergbrain. Andrew, you want to come on screen? I had to scroll. I'm sorry. You've probably been there forever. I'm just going to add you, and if you want to jump in, you can. Sorry about that. I was wondering, how the heck is he chatting with me when he's not in the Streamyard? Oh. So, all right. You want me to jump into a CAD program and show you what this looks like then? Would that be useful?
Specifically, KeyCAD is what I'm interested in, because that's what I've chosen to use. I think I get the concepts of moving things around, but actually on the Pico, right?
Yes.
The reference point for the pad, did they dimension their drawing to the center of the hole?
No, these bastards. Okay, so they used a datum. So most of the measurements are given relative to inner and outer pad dimensions.
So they're edges. And then you converted them to centers, right?
I converted them to centers because, see this little point right down here?
Mm-hmm.
So they created a datum, which I believe is supposed to be the bottom left edge of the part. Right down there?
Yep.
And then they measured these pads off of that datum. So my thought was, if you are using a program where everything is grid-based, it would be so much easier if you just set a grid that was, say, like 0.1 inch spacing, 2.54 millimeter, right? So if you set everything in that direction, and you go up that way, and you go up that way, it would help. At least then you've only got to change your grid spacing a few times to set things.
So what I'm thinking is, it seems like the hole is the important feature. I mean, if you were doing a through hole, is the thing that you would care most about being aligned. So if you drew your, for example, your land differently, like as different total width than the than their drawing, it would offset all the holes out because you're going off the centers of these, not the centers of the holes. Like, it seems really easy to shift everything unintentionally.
Oh gosh, yeah, absolutely.
Because they're drawing, that is of the. I mean, where does the hole belong in this drawing here?
It would be to the left of the center line.
So it's to the right in this case, right? Or we may be mirrored, but
we could be mirrored. Okay,
it's in that sort of radius end.
So let me just let me grab a marker and I'll just draw where the holes would be approximately. So the center of the surface mount pad is there. It's indicated on the drawing.
Right.
The holes would be there for the cancellation.
Yeah.
And then there for the PTH hole. And those would be 0.1 on a 0.1 inch on center grid, some distance apart here.
Mm-hmm.
So those things would be, and I don't know if I have a ruler handy, but call it, say, 0.8 inches apart or whatever it is. They would definitely be point something apart. If I have another one, I can tell you. One, 2, 3, 4, 5, 6. Looks like 0.7. So these things are 0.7 inches apart. So if you could get that thing started on, a 0.1 by 0.1 grid, you could set those things. You could set up 40 pins really quick.
Right.
if that makes sense.
And then it means that your actual holes in the drawing will each be halfway between one of those points on the grid of that size. Because your pad center doesn't align with a hole center.
Yes, it would be a different pattern for a plated through hole. Okay, give me a second here. Sharing your screen. Let's stop sharing. Let's get back to StreamYard. Okay, so I'm downloading KiCad right now.
Okay.
Or at least I'm hoping to. I don't have it on this laptop. I don't know how long it'll take. We're going to find out. From CERN in Switzerland. We'll find out. If it takes too long, I will just kind of do a demonstration using only grids and dip trace.
Yeah, no problem. I could share two, and we could go through one or two.
You want to do that?
If you're up for it, yeah.
Yeah, it looks like it's going to take about 10 minutes.
It's a slow download for some reason.
Yeah.
Sure. Yeah. Let's make a funny shape pad and then try to align them correctly.
Okay. Do you have two screens or just one that you'll be sharing?
I have 3 screens.
Ooh.
I just got to pick one. Let's see if number 2 is most likely correct. Is that right? Oh wait.
You'll have to share. Add.
Sweet.
And then what's going on?
You can see KiCad?
Yeah, you're up.
Cool. Yeah, so
I just need it to be bigger. And I did that a minute ago. Keep full screen layout.
Let's get this thing to open up here.
How did I do this a minute ago? Boy, I tell you, I'm a mess. I don't know what I'm clicking on. Oh, there it is. Okay. You are full screen, sir.
So let me see. What page of the data sheet is that on?
On the 40-page document, it's not too far in. It's like page 7 or something.
Okay.
I can find out for you if you need me to.
Let's see what we can do here.
Not that document.
Not that one.
Oh, no, that's the Raspberry. Wait, go back. I'm sorry. Maybe it was.
Yeah, because we've got the 2040 and then we've got this guy.
Yeah, we don't want the 2040. There you go. There it is.
So we've got. Let's see if we can get that to stick over there. Nope, not going to happen. All right, we'll just flip back and forth. So I guess the first thing that's interesting is they don't have a through-hole footprint, just the surface mount one? And they've just got this drawing.
That's the through-hole one, yeah.
Okay, but no dimensions.
No.
So the thing that gets me is like, we can make an assumption that this is an even, 0.1 of an inch, right? Interval between the holes. Mm-hmm. But here they're dimensioning between the pads, like the edges of the pads. Like, anyways. So yeah, let's give this a whirl. So I'm gonna, let's see, what's the best way to start here? Let's set my grid to 0.1.
0.1 inch, 2.54 millimeter.
Yep, got it. Start here, add pad.
Sure. Are we going to do the plated through hole or are we going to do the surface mount?
Let's do a surface mount one. Although, would anybody be sad to have a plated through hole in their surface mount pad?
Yes.
So you could socket it if you wanted to?
Yeah, you don't ever want to do that because the solder will all run off of the surface mount and into the hole. So your surface you'll get weak surface adhesion.
Now, would that be so bad with the castellated edge, though?
For hand soldering, you're going to be fine because you can just add solder until you've got a good fillet. But for an assembly, if you're going to send this off to assembly, you would never want to do that.
Makes sense.
Because they could
Okay.
never put enough solder paste on for it to work.
All right. Let's make service mount. So
Okay.
I'm going to make an assumption that I need to get in here and do some of this. And
I can give you the dimensions if you want for each pad.
Soldering.
yeah, who knows which one to choose here? Do I want custom? Because obviously it's not a regular shape.
I can't see it. Is there a D-shaped or a rectangular?
Circular,
rectangle?
oval, rectangular, trapezoidal, rounded rectangle.
Let's try rounded rectangle.
I don't think I can specify the radius on either side separate from each other, though.
Oh, that's okay.
Well, I think we need to, right? Because wouldn't we end up with a jelly bean shape if we do this?
Yeah, jelly bean's fine.
Okay. I was going for the D shape. I mean,
that would be ideal if you can make it, but if you can't, that's okay.
Well, let's see if we can make it. Also, I noticed there's some that are slightly different than the others. Are these the ground pins? Or are they just every fit pin? Mm-hmm. Regular spacing. Okay. Right. So if you don't know how to customize this, I don't either. But let's just go with rectangle for now.
It's a lot quicker.
All right. And what is the dimension of the pad?
3.2 by 1.6 millimeter.
All right. And this looks intimidating. So let's just go with rectangles for now.
Okay, it'll be fine.
All right. And then, so their datum is not on the center. It's on.
Okay.
I'm looking at this. It looks like half a hole. What are we doing?
Yeah, their datum. It's nothing good. It's from the bottom of the pad number 20. It's 0.57 millimeters down, and from the left side of pad 20, it's 0.79 millimeters from the edge. Have fun with that. Here's what I would do. Don't worry about that datum point. Start
just align these. Yep.
Start with an array of pads going down the side. You need 20 of them for pads 1 through 20 on the left side. And I'm going to see if I can't make you bigger just so I can see you.
Oh, yeah. If there's a setting I have, just let me know what to change.
No. It's all on my end. You're fine. Brian, I'm going to put you in waiting room for now, buddy. Okay. And then, all right, sir.
All right. Made some pads.
Sweet.
So that's pretty straightforward. I'm going to guess, the zoom is funky here. If I were to duplicate this, so, okay, what other dimension do we have? We have the center to, no, we don't have center to center. How far is it from the center of this pad to the center of this pad?
19.38.
Okay, so here I would use the move exactly 19.38 millimeters to the right, and this should also be 21, right?
No, that's pin 40.
Or is that 40? Yeah.
Whoops.
Wait, we figure it out eventually. It doesn't work. So here we are. This is the other thing that was bothering me is I would love to measure I can measure from centers of objects,
Yeah.
but I would love to make this measurement from like inside of pad to inside of pad, and I find that I just can't, with one exception. I cannot get the cursor to stick to any logical thing here other than a grid
No.
or a center unless I go tiny with the grid.
For a hypergranular grid, yeah.
Yeah, so we could go like tiny, and then we can measure from here.
Which will get you close, but it doesn't get you the accuracy that you want coming from a CAD program.
If you zoom all the way the heck in, we get the right number. So, I mean, you can do it, but that's a challenge.
Yeah, our number should be 16.18, I think.
Okay, so we got it.
Yep.
Okay, and this is probably going to backfire if I try to make an array of these. Can I count down? I don't know. Oh, I have an idea though. Let's go from 21 and count up to 40. Of course, these are now in the wrong position, right?
But you can spin them
I
all
can
around.
rotate them
reflect
twice. Yeah, let me fix this grid here. So I think I found that when you is rotate R. Yeah. So here's what I learned, in case anybody's curious. When you select items and you rotate them, select items. So I'm hitting R to rotate. It rotates around your cursor. So if you have it here, it does some crazy stuff. It doesn't necessarily rotate around the center of your
that's
situation.
frustrating.
And you can also see here that these are in the center, but now it is where our grid doesn't align anymore on the second set of pads because this is, well, because it is. So here we could do, I don't know, I'm not an expert, but why don't we rotate them around this way and then we move them. Oh, yeah. And tell me why when I hit M. Okay, so it picks them up to move them by wherever your cursor is as well. And now my reference point is, I just want to pick up the center of the pad, right?
Right.
You can see where I'm thinking is I'm going to pick it up, slap it right on top of those, and then move it again to the exact distance it needs to be away. I can't, I believe I have this turned on. Somewhere in here says magnetic pads, which makes things like the measuring tool. You can see the circle on the cursor, it snaps to the center of the pad. But when I'm using the move command, I can't select the center of the pad unless I do something different.
So how about this? What if we delete everything but pad 21, get pad 21 properly positioned, and then create the array there and rotate around the center of pad 21? Would that do it?
You're assuming I can select the center of pad 21, but I think, yes, I think you're right. We just have to get it in the right place. So you notice when I copied and I'm pasting, I have the center highlighted. Perhaps what I should do is put the center on one of my grid positions, anywhere. And then hopefully the next time I select it, it'll snap again to the center of the pad. So I think the reason I couldn't do this is because I had moved the pad and it didn't align to the grid anymore. The center didn't align. So let's try it this way. And we're going to start at number 21. Okay, so now that these are, at least we know this one is aligned. Let's not do that. Select them. and then move them relative to that point. So I could set them right here and then scoot them over if they stay selected. If they don't, I'm never going to pick them off of the other pads. So they did stay selected. That's great. Now we should be able to move exactly this distance again. So I don't know about you guys.
Your numbers are off.
Because I forgot to flip it around, didn't I?
Yeah.
Okay, let's rotate it and retry.
I just texted Jesse to see if he can join us.
Yeah. I know these things aren't impossible, but I do feel like this is a bit... Whoa. Okay.
More difficult than it needs to be.
A little bit. All right. Put them on top. Move them here. So in theory, these are correctly positioned in relation to each other.
In theory, you now have everything you need to do for your Pico. Right? Everything else is gravy. All the rounding edges and everything. Those do create for better solder joints, but these will solder just fine.
Yeah.
So
yeah,
in theory, this is enough to get your Pico attached to your board.
Yeah. That should do it.
Yeah. So I only say that because I know some people are going to be frustrated beyond measure, and you've probably already spent, an hour on messing around with KiCad on this type of thing.
Yeah. I mean, you could find workarounds, but it's always, I always question if I should be finding a workaround or if there's like some knowledge I'm missing that would make this very straightforward. And I'm sure there's probably a wizard out there and someone's got a Python script that'll do it, but
click back on a pad for me, if you don't mind, and zoom in.
Here, let's pick one that's not got text on top of it. Oops.
Well, no, I want to see the screen, the contextual menu that comes up.
Oh, gotcha.
What about properties?
All right, so properties is E.
Okay, so it looks like you can set position X and position Y. You can manually type them in.
Yep.
So that can help us locate the next 3 spots. What about setting your origin? Can you reset your origin?
You can. I think the space bar does it. So relative to where your cursor is, you have these, you have like I guess it's that one. Sorry. Okay. So this origin can be set by moving your cursor and hitting space. Or is it that one?
Is that the origin of the entire drawing or the origin of that pad?
The origin of the drawing stays static, but I think what I'm changing here is it like a user origin. So now maybe it's not an origin, but this readout of like distance, you can zero it with the space bar and it becomes relative to where your cursor is when you hit the space bar.
Okay, so then the next thing that I would do, once I had these down, let's say I wanted to get the USB connector in the middle, right?
Right.
So those are measured off that weird datum that's off the bottom left corner of your drawing. So I would shift everything up above that.
So in this program, Y is negative.
No.
Or Y is reversed. But yeah.
So right now the center of pad 1 is 0, 0, correct?
Currently, yes.
So I would want to shift everything up.
You want to basically move it so the origin of the drawing is this point.
Yes.
Okay. So that'd
be, close to, it's not exactly, but it'd be close to 50. And I would definitely want a calculator for this. It's close to 50 millimeters up.
What is the distance? What's the X and Y between the datum and the center of this pad?
The datum in the center?
Yeah. So this coordinate of this pad relative to here. I think you had that drawn out, right?
No. but I can figure it out quick enough.
Okay, yeah, because what I need to do is move all this junk up and to the right so that this is my 0, 0.
Yeah, I was just looking to see if maybe Jesse had joined us or if he was going to join us. He hasn't responded to my, do you want to join the live stream? That's a smart man right there. He knows to get when the getting's good.
You had centers, though, of each pad, right?
I do. Would you like to see those?
If we can move the center of, if we can use this point and move it, then we can accomplish the same thing. So what's the center of the upper left, I guess pad 1?
0 and 48.26. Oh, yeah.
Okay. 0, 48.26. So if I move this from 0, 0 and I move it up 48.26,
then we don't need to care where that datum point is, and we can use my numbers instead of the ones in the Pico manual.
that's what I'm thinking.
Yep.
Yeah, okay. So since you've done the math, we will just move this vertically.
I did
0 and 48.26. Here's something I like. I mean, don't like. Up is down. So negative 48.26.
Oh, a
moves us
positive
up.
Y is down.
Yeah.
Oh,
I
man.
realized Inkscape is the same, but I find that quite exciting.
Interesting.
Okay, so now we have 0, 0 in the center of pad 20.
Okay, well then if that's the case, you can create your 3 new pads. They do have different dimensions, but we don't need to worry about that right now. Are you able to see my screen, or would you like me to read them off to you?
Oh, I can see it. So let me just make the pad here. Those are probably something like 1.6 by 1.6. And we wanted a through hole on these.
Yes. They're actually pads A and B appear to be 1.1 by 1.8, but we're not going to use those. We're going to make our own. So yeah, you could do a through hole. That's maybe 1.6 by 1.6.
Okay. And hole size. What is normal hole size?
Well, normal here is a relative term since we're kind of jimmy rigging stuff together.
What's the hole size that you can solder through?
Let's call it 0.5 millimeters.
Okay, that's pretty small.
That is really small. Let me see what I've done here. Give me a second. Remember, though, all you've got to do is let solder melt in that hole.
Yeah, there's probably a minimum size.
So here's what I did. 1.8 by 1.8 for the pads with a 1.5 millimeter hole.
Okay, so big hole.
That's a much bigger hole.
I'm guessing you can get away with a lot of... there's probably a minimum size, but not a maximum.
There is a maximum because you still need an annular ring around that hole.
Oh, yeah. I mean, yes, there's a maximum. But I'm guessing if you go so small, like a via, it'll just, like surface tension of the solder will make it not go through. Or something unfortunate that would be hard to fix because it's...
Well, this is going
right
to be hard to fix. If you screw this up, getting the solder out of that hole is going to be pretty much impossible. The way that you get around that is melting a 4-eutectic mixture into the hole that drastically lowers the melting point so that you can just pull it off. You just heat up the board with a little hot air and the whole thing just pops off because you'll never get the solder out of that hole while it's on the board.
How did you number these?
Top left 44, top right 45, and then ground connection 46.
Okay. Let's see.
I did the SPI interface at the bottom as 41, 42, and 43.
Okay. Just 46, and we are. What's that first number there?
9.69.
Negative 44.91. It's covered up by your name, is all.
Oh,
Okay.
sorry.
So it's easy when you do the math for us. I like
Yeah.
that. But
Yeah.
we're supposed to trust and verify here, so
You need to verify.
I have to do the math again, anyways.
But yeah, working off that Pico data sheet, when the Pico came out, I had that pattern redrawn within 2 days and posted on our website because I saw how just miserable that was going to be.
Yeah. So I have a thought on this.
Sure.
I've been able to import a couple of DXFs, but I'm wondering if you could sketch this in CAD where you can do dimensions between edges arbitrarily.
Mhm.
Draw the whole thing and mark out every center and just import it as like a bunch of points. And then just go through here and like draw your pad shape and snap it, like paste it on every single point to kind of get away
Absolutely.
from the math problem part of it and just worry about making the right shape and slapping them on the points.
I think
Then-
that would be good.
Yeah, keep it on one of the layers that don't matter and remove it later.
Yeah. Brian, I've added you back in now, buddy. We can spare the screen space.
Thank you.
No, thank you, buddy.
Question: do we need those three things up at the top? 44, 45, 46. What are we using those?
Yes and no. So every time that I do one of these courses, I try to come up with something that will illustrate all common communication modes. So I2C, SPI, USB. So you don't really need it for your circuit to work. You do not need to add a USB, but I wanted to add a USB just because it is a pretty common mode of communication, and I wanted to illustrate some best design practices with it.
Okay.
So no, you don't need them.
So these are I guess it's TP 4, 5, and 6.
Mm-hmm.
What do your numbers come out for those?
Sure. One moment. And I don't know that we need those 4, 5, and 6, but they're all centered at 7.19 in the X. And then are you able to see the screen there for the Ys or no?
Yeah, except for when you type them in as regular numbers, they go south.
Oh, sorry. Yeah.
Okay.
North is south, south is north.
Okay, so we got, what are we?
What are you showing us, buddy?
This.
You ought to recognize that.
It's the Pico, yeah, but
I have one. I got mine.
Oh, yay! That's cool. Okay.
I was doing it for order anyway for this other project, so I dropped one in since it was there. They had them.
Yeah.
It was easy.
You had me worrying I was screwing something up there. So.
No, I was just saying, hey, look what I got.
Nice. Yeah, Wednesday is going to be really
soldering. This is really aggravating.
Wednesday is going to be exciting for everybody, though. Watching your stuff get coded live on screen is going to be fun. Brian, do you know what a solder pot is?
No.
Basically, it's just this little hot plate that has a crucible on top, and they're like $20, $30. You melt a bunch of solder in it, and you buy bar solder, so you're not melting a bunch of wire.
Right.
And then when you're soldering a bunch of wires, you heat that thing up. It might take 20 minutes, and you dip your wires in to tin them.
Yeah.
It's like fondue.
Yeah, I actually did not tin these. I pre-tinned, I pre-soldered the pads, and I've got a little bit floating on the end of the iron, but it's working well enough for now.
Good.
At least I think it's working. We'll see when I plug it all back in.
Yeah.
I now have a whole bunch of little NeoPixel dots with wires on them. They're not connected together yet, but I have a string of 4.
I want to do a quick experiment here.
Okay.
I don't know what I'm doing, but I saw a menu option that looked great. This is the wrong size, of course, but I saw create pad from selected shapes. Small anchor. Okay, we'll figure that out some other day.
Can you do that from a square and a semicircle that are joined together instead of because it looked like you had outlines?
Yeah, so I suspect I need to draw all of the parts of a pad. So this is like a hole and some other things here. So I'm not sure what to do. I don't know what it's expecting
Right.
for a shape in order to convert it. We can deal with that later. Okay,
Yeah.
so yeah, I mean, that's, I guess, the basics of it.
Yeah.
The hard part is you do all the math. I'm dreaming of a place where like I just pick up a dimension, slap it in here, type a number, and it's constrained like normal CAD software.
That would be nice. Yeah. They
And
didn't
that
do
is
that
why
for
I'm
you.
using. It's one reason I'm using Fusion or Eagle, either one. It's
Well,
much
it's
more
not.
CAD-like.
Yeah. Well, and it's not all of KiCad's fault. Part of the problem is that the Pico people, they laid it out in a manner that isn't conducive to importing into CAD. I mean, granted, KiCad's not doing you any favors, but
But one thing about in Eagle, you tell it the pad shape, and you drop a pad. You don't. I guess I'm sure you can adjust it if you need really tight things, but so far it's been pretty quick for those kinds of things.
I do have a tip for anybody who cares.
sure.
Don't draw something on the wrong layer, especially if it's more than one object, like this shape. If you accidentally drew it on something you didn't want,
Yeah.
you can move it. Fantastic. You can
Woohoo.
only do that one item at a time. You can't open the properties menu on more than one object at once. So if you drew like a huge work of art and it's on the wrong layer, or you wanted to duplicate it onto, say, the solder mask layer and have another version of it that you modify so it's like a mask type of situation, you can't just do it. I'm gonna say you're gonna have to export it and re-import it somehow. You can't move like
It's about as bad on that.
Yeah.
Since my board outline was the same as my silkscreen outline, I figured I could just use the same thing. No, it's two completely different kinds of entities.
Yeah. Oh, I learned something else too. The solder mask layer, when you import it, or I guess when you draw it as well, is not how you would imagine. It's inverted. You should think of it as not solder mask. I actually don't have my example because I think I deleted it.
Maybe you can clarify that. What do you mean it's not solder mask?
It's not solder mask. It's like anti-solder mask. Let me find my drawing I did for the example I posted in the forum. And I used that SVG to Shenzhen plugin from Inkscape, which was great. I'm just working on finding the doc. I have a lot of files with it, but I was going to show you how the. So here's the design from that post, and we can see that the way I drew it was meant to be more like how I want it to look. So I made a black area here that would represent silkscreen. The red area was meant to be the solder mask, and then the uncovered silver was meant to be just exposed copper with the
Okay.
tin on it. So I picked my colors and I did art, which was fun. But in importing, I found that what would happen is this red area doesn't indicate where you want the solder mask to exist. It indicates where you want it to not exist. So if you bring this in importing using that plugin, you'll end up with the solder mask over these silver areas and then none over the rest. Does that make sense?
It does. So you need a negative of the image.
Yes. Right. And I'm going to see if I can find that file and show you what it looks like when it does work.
Sure. And by the way, I've opened the waiting room again. If anybody wants to come and join us for anything, please do while we're looking for that file.
Yeah, let's see. Nope.
Yeah, I'm still learning the ins and outs of Streamyard. It's got some cool functionality.
Okay, this took me a million tries, by the way, if anyone thought it looked easy.
I think that's what everybody thinks when they look at PCB design. That just looks easy.
Also, this was, if anyone's interested, a fun way to pick a color combination. You're kind of stuck with a palette of like 3 things, but you can duplicate your art and just go through all the possible combinations till you find one that you like.
Nice.
Yeah. So I might actually not have it. So let's just say I'll be done sharing for a while until I dig something up. But I think if anybody has a question, I'll try to help you because I've had experience of 1 with this so far, and I got it to work. So
that's good, man. You're doing good. Well, actually, we're just at about an hour. So if nobody has a question, I mean, we might as well call it. That's a lot to ask people to hang out for. There are people leaving comments and they're all people watching, but I don't see anybody else in the waiting room. So
I'm gonna have to take off. I gotta go see the grandkids. So
absolutely
priorities,
No, thanks for joining us, Brian. And I was thinking we might do the same. But I really do appreciate, Elliot, you working through that with us. That was great. Because that's what everybody's going to have to do. So Morphine agrees that, yes, that is annoying about KiCad. I agree too. Michael was asking about it. I think we did that way back at the beginning of the stream. So, well, hey, man, I appreciate it. Thank you so much.
Right on. See you guys.
All right. We'll see y'all inside the course. Make sure you're staying active and interacting. Remember, if you do get overwhelmed, we will provide you a checkpoint to jump back in at the end of the week. But I would like you to try, because this is a skill you will need. It's nothing you can get away from for too long in engineering. All right. Take care. It's Teach Me PCB. I'm Mark, and that was Elliot. Thanks, Elliot.